Me. And if you could maybe just, if you want to move this now, we'll get these set up here. He's just going to adjust the mic there.
Yeah, try to
Feel free to stand up and stretch. I know we'll take a break after Juan's presentation and get some coffee and move around a little bit. So.
I think his name is Nitin. Is it Nitin? Nitin, sorry. Nitin mentioned about 2019. And I remember that time with network automation and how we had two sets. We had the side where it was all in on network automation, and then we had those that are traditional, networks are stable. I've seen this happen a million times. I've been automating networks for years. This is nothing new. I think AI has kind of shifted business as a whole. Not just network engineers, but how we work in general. This talk, the TLDR, is about AI agents. I've been on this journey since 2023. And when you talk about, when I started in 2023, the conversation was around hallucinations. That conversation's kind of quieted down because AI is improving. So as we talk and go through this presentation, I want you to have an open mind. Now, let's kind of level set something we all agree on. When it comes to network engineering tasks, configuration management, network troubleshooting, capacity planning is something we all kind of face. It's a data-driven solution that requires intelligence. So the intelligence that your network engineering teams have is always going to be required. But the thing is, this is data-driven. Can AI help with this? Yes, but there are challenges. So I'm not here to sell you on AI because there are real challenges trying to just roll out AI and solve these problems. It's not that easy. So don't think I'm here to try to say AI agents are the solution. They can be the solution if you know how to use the tool. If you have the intelligence for the solution and you understand the tool, you can really get a lot of things done. And so when we think about this, from Gartner's research, the number one topic of 2025 is agentic AI. In 2024, I did a talk at Otakon too, and I was talking about a network agent that has access to tools, memory, planning, and all these things. And here we are, that's actually being rolled out. By 2028, 33% of organizations will have some type of software that includes agentic AI. How many of you are running agents today? How many are building agents today? Okay, here's a question. How many of you want to enable your teams to be more productive? Let's talk about that. Now, before we do, 40% of those projects when you build agents, by the end of 2027 will fail. So like I mentioned, I'm not here to sell you on agents. It's not that easy. You think it will be successful, but then you realize, well, I don't really have good data to get an agent. I really don't understand how to manage this at scale. It worked on my laptop, but once I tried to build this in production, it didn't really meet our needs. And so 40% of those projects will fail. They're already failing. There's no research on this. And so when we think about the level of success, I break this up into two paths. The first path is just buying a tool that works. And we'll talk about some of those tools here in a moment. The other path is for those that have the skill set is actually building something custom because the tools that you want to buy do not meet your needs. So we'll talk about both approaches. Now, some of the top telecom agentic AI use cases is around customer experience. They're building agents to help customers have their own unique experience when they're using their tools and their applications. They're enabling their enterprises to be more efficient. We talked about increasing teams of productivity. They're creating workflows that are agentic and providing tools that are agentic and helping their teams be more efficient. And then around network automation, they're helping mediate downtime and process improvement by leveraging agentic frameworks and workflows. So how do you get started? This is where I like to have fun because I like to actually get technical and build these things and use the tools that I talk about. So we're going to talk about when you start and think about agentic AI, you really need to kind of work backwards from the problem. What are you trying to solve? Right? And I'll show you this on a slide, but if it's a deterministic outcome, you probably can get that done with traditional code. If it's non-deterministic, then that may be a problem for AI. And so when we think about the agentic use cases, we can break this up into 4 quadrants. We have the long-term plays, where they're kind of moderate value, but they're high effort. Think RAG. How many of you have tried to roll out RAG? Right? The value is okay, but that can be a really high effort because you really got to think about the data. Like if you can't get that data right, you don't provide a good data, you're not going to have a good chatbot, right? Moderate effort, Copilot, right? Just enable your teams with Copilot. Giving them an assistant to help them write applications. That's kind of moderate. Now, high effort will be figuring out, okay, we are really trying to monitor our networks and understand what's actually happening. We want to build an agentic framework that understands our network. That's going to be high effort, but it can be really high reward if you can figure it out and get it done right. Now, I mentioned the traditional workflows in agentic AI. This is kind of so you can visualize it. So if we look at the traditional paths, specified, deterministic, clear, repeatable processes, accuracy, and to solve those specific problems. We've been doing automation for years. That works. Now, when we think about agentic, if this could be a million different use cases, you don't know the inputs that's coming into that agent, right? You need the agent to be able to reason, establish a plan, take action on that plan, observe the results, decide if it needs to take new actions and update the plan, and continue that until it achieves the goal. And so when I look at this from the traditional path to the AI-assisted path, the automation barrier, I believe, is gone. You have a team of network engineers and architects that can leverage these tools today. The time it used to take to learn Python, to study the frameworks in Python, NetMiko, Nonier, all the different frameworks, to learn the organization, to learn Git, to learn DevOps, to learn Linux, something as simple as Linux. It takes time for network engineers to get up to speed with that and maintain the code base. Now we look at the AI-assisted path. AI is at a point now to where if you don't understand something, you can ask, right? The challenge is your business logic. Your domain-specific questions, you as a practitioner, your teams as a practitioner, have to understand and give it the right context so it can analyze it and then give you the right response. That's where your intelligence comes into play and your team's intelligence comes into play. And so specialized agents. We have Amazon QCLI, Amazon Q Developer, Claude Code, Kiro, Cursor, just to name a few. Now these are tools that have agentic capabilities. Some live in your IDE, some live in your terminal. I live in my terminal all day. I don't come out of my terminal. I'm gonna show you an example of one of my workflows, but my entire workflow is in Claude Code. Sometimes I go to Cursor or just vanilla VS Code, and I use QCLI. When it comes to the data that I use, I work for AWS. So when I use Claude Code, I don't have to connect to Anthropic. I connect to Amazon Bedrock. So what does that mean? My data lives in AWS. So nobody's training on the data that I use. So when I'm giving it my data, I'm giving it challenges, that data lives in AWS. So when you think about the security, the privacy, the governance, you can build these applications, use these applications, and figure out how it works for you with the right provider. So let's talk about a demo, a real use case, PCAP analysis. Analyze the PCAP in this directory and identify any issues present. Document your findings in a markdown file, save it in my Obsidian vault in a folder called PCAP analysis. So I'm telling it, okay, analyze this PCAP. it's going to have to look in the directory for the file and recognize that it's a PCAP file. Then it's going to have to figure out how to analyze that PCAP. From there, it's going to have to take the findings and create a markdown file that I can read. I can take this a step further. I need to talk to leaders and tell them why this happened, why it's important, and how we're going to fix it. I could be more specific, but the agent is going to figure out what to do. I'm going to let it be creative. And then it's going to have to figure out this MCP server. This is an MCP server. Obsidian is like Notion. So it's going to use MCP, connect to my Obsidian Vault, and save the results in this folder. So let's actually look at this demo. So the first thing we're going to do, we're going to open up Claude. And then from there, we're going to paste in my prompt. Now, once we paste in my prompt, Claude is an agent, so it has access to built-in tools. So it's going to analyze and create a plan on what needs to happen. It does something cool. It creates a to-do. So now it has a list of actions it needs to take. So it's going to analyze the directory to find the PCAP file. So you see the list in my directory, it found the PCAP file. Now it's going to analyze the PCAP file. What will it use to do that? It's going to determine what tools it uses. It asks me for permission first before it executes that tool. It's trying two tools. It's trying T#, not successful. The agent's going to have to update the plan to figure out the right tool. TCP done works. I'll use that. Now it's analyzing my PCAPs. And all of this is in real time. This is not sped up. And so when you think about this process, what's actually happened, if I'm on your team, I'm a network engineer, I could be getting coffee, or I can be working on another ticket, or I can automate this entire process because this can be executed command line. So when you think about the amount of time you can save to increase your productivity, using these tools can enable it. And so now it has an analysis. It's creating the file inside the Obsidian Vault. It's asking for my permission to execute this MCP tool. And then once it's done, we'll see the results and we can take a look at it. But the agent doesn't have access to just go take actions. I'm the human in the loop. I'm analyzing what it's doing, the tools that's being called. And then you can actually build observability in this with something called hooks. So that way you can monitor everything that's happening within your teams to understand how they're using these tools, the tools that's being called, and et cetera. So here is the results of the PCAP. Now, I will say I got this PCAP from Wireshark, which is publicly available on the internet, so it may be in the training data. But from what we see, it was able to analyze the PCAP and give us the results and recommendations on how to remediate. And as you can see, the default password is Cisco. It suggests hardening. It's 198 packets. The time span of network activity, and it gives us the entire results. That took 2 minutes. 2 minutes, right? How long would that take your team? And I could tell it, okay, we need to do the source and destination. Send me your PCAP, do a TCP dump. You don't know how to run it, run this command. Have Claude generate the command, send it to the developer. All right, send me the PCAP, and I analyze both of them at the same time and have it evaluate both results and figure out what's the use, what was the issue, where are we having trouble with these connectivity. Now, that's a specialized agent, something that we can deploy today. What if you want more control or more customization? What does that look like? Building an agent. You have your large language model. Now, in the center of this large language model needs to be capable. It needs to have some sort of reasoning capability. Every model is not going to be the right model to have agentic functionality. It needs to be able to process the information that comes into it and create a plan and then be able to make tool calls to take actions on that plan. And so some of the tools that you need memory, short-term and long-term. If you're building an agentic workflow, the system actually needs to maintain context, right? So you need to be able to manage that conversation, short-term and long-term. You can only fit so much data inside of a context window to a large language model. So once that data gets full, you got to have a strategy to handle that. And then from there, you have tools. Get interface, get weather, connect to this device, all of these tools, and then your data, understand your business logic. And on top of all that, Observability and guardrails. If you're building a custom agent, you have to be able to observe and trace what the agent is actually doing. And you actually have to have guardrails in place to say, don't do that on the inputs and outputs, right? And so some of the agentic frameworks that are out there, you have frameworks from Crew AI, AutoGen, LangGraph, LangChain, Google ADK, and from AWS we have a new framework, an open SDK called Strands Agents. And so if we look at Strands Agents, it supports MCP and A2A. In 3 lines of code, you can build an agent. From Strands, import agent. We initialize the agent. We pass in a prompt. The agent is up and running. Simple as that, we have an agent. Now, this runs on my laptop. You have to have the deployment strategy, and we do have a new way to do that with Agent Core. We can talk about it in another conversation if you are running agents or interested in building and deploying agents at scale. But in this example, I'm running this agent on my laptop just so everybody understands, and it's connecting to Amazon Bedrock as the large language model. Now, when we talk about this demo, like I said, I like to talk technical and let you all know like what's possible. So there's something called meta tooling. And if you think about what we've been discussing, we've been talking about a large language model that has access to tools. Since these models are capable of creating a plan and understanding what needs to happen, in your infrastructure, you can have a plethora of tools that needs to be executed. With meta tooling, we simply just pass in a prompt to the agent. The agent has access to an editor, so it can write code. It can write its own code. It has access to shell, so it can run shell commands. That's all it has, 2 tools. From there, it can write its own tool, right? So it writes the Python file as a tool. That sounds cool, but it can load that tool within itself, within the same runtime, and then use that tool. Now, I'm showing you this because we're going to talk about I'm sure we'll talk about multi-agents, and we'll talk about agents that can self-extend. This is what you're seeing. So this agent can actually write a tool or write another agent. So you can actually have some really complex solutions. And I'm going to show you an example of what this actually looks like. And so we're going to do a network interface audit. Create a tool to check if the router interfaces have proper descriptions. Here are the requirements. Connect to our live router via SSH. Check all interface descriptions. Flag any without the pattern. We give it the pattern. Generate a fixed list. Use the tools to get the results. All it has is an editor and shell. So we're going to start this demo. And when we list the files in the directory, I have a tools folder. The tools need to be stored in that folder. My system prompt guides the agent on how to do this with Strands agents. So we execute the code. You see the 2 tools are the editor and the shell. You see the prompt, and here's the agent's thinking. This is how it's going about establishing what it needs to do. So here's I need to create a tool. It's already created in the editor, right in the code. It needs to use NetMiko, get interface information, flag interfaces, generate a list, and then print the results. And so now here's the first tool it just created. Check interface description. So it created a tool and loaded it within itself and used it immediately to connect to Cisco DevNet. And it's getting the interface information. It's not running this through CLI. And the reason why I'm showing you this, because now, if you're trying to figure out the right tools to use, you can actually use an agent to, in a dev environment, test your environment, create tools, and use these tools and pass them to your team. So you can kind of create a tool catalog of tools that are tested by your agents with guardrails. And so now the agent is still getting in interface information. It's on its 4th tool call. Actually, 5th tool call, because now it's reporting interface compliance. And I'm using something called hooks because I want you to see this. What you're seeing is that your output from the agent that's being input to the tool calls. Because if you're trying to log your agents to see exactly what you're doing, this is how you can monitor that and have observability. You can use hooks and go back and trace. And as this is happening, we're seeing real time the agent log into the device, check for compliance, and then print the results. And so that's what we're seeing here. We are in a new paradigm where we are all enabled. This took about 15 lines of code to build an agent that can write his own tools and go out and solve network problems and help me save time.
That's
and it took
really cool.
8 tool calls. A total of 8 tool calls. And this is real time. This is all happening in real time. And as you can see, the tools are now loaded within Python. So it didn't run these tools with shell, it loaded it within itself. Now, we gotta talk about risk. We can't just show you some cool stuff and not talk about risk. So when you're building these agents and these applications powered by agents, you gotta have the guardrails in place, right? We can't just let them run wild because as you can see, they can write their own tools and execute them. If it has access to shell, you gotta have the guardrails in place to ensure you know what it has access to and what it does not have access to. And then there's risk when you're acquiring third-party agents as well. If you're using a third-party tool, but you're sending your data to that provider, you need to understand that they're training on your data, and also you need to also protect your intellectual property and security, right? And then there's risk with humans in the loop. I had to approve the agent to take action. But if you don't review what the agent is doing, if you just accept all, you gotta be cognizant of what's actually happening. And then from there, agents that act autonomously. If those agents are left to just roam your network, how do you know what they're doing? How do you put those guardrails in place? How do you limit their access, right? And so, the next to the last thing I want to talk about is when to use agents and when not to use agents, just so we can come back to this topic. Traditional, deterministic, go ahead and use code, right? Non-deterministic is a great use case for AI and agentic AI. In closing this out with a quick story of the evolution, we are evolving. 2023, we had chatbots that were helpful assistants. The code kind of worked. 2024, they got a little better. They started having tool capabilities, right? You could actually build something that works and a little more helpful. Now, we have fully autonomous systems that are being deployed. If you do some research on GitHub and the Claude Code on GitHub, people are actually building Claude Code into their GitHub repos and then using them to monitor pull requests and update issues real time, autonomously, right? We are in a different paradigm, so our teams need to be enabled to use AI and not guard it against it. Enable them to just scale, to be more productive, and just evolve. And with that said, what to do next? Begin with a coded agent like Claude Code, Kiro, or Cursor. That's the fastest way to get your teams up to speed with learning AI. Use MCP servers. Now, there are some security around MCP servers, so be sure to do your research on that and tools, but it will give your coding agents additional capabilities. And then pick one repetitive task and use an agent to automate it, evaluate the results. How does it compare to if I did this manually? How can I improve it? How can I scale it? And then find another task and repeat. This completes my presentation. My name is Lightfoot. If you're interested in the presentation, the code, and all the good stuff, here's a QR code. There's also a survey. If you fill it out, it'll help me improve future sessions. Thank you.